digital lecture series. I am Ferdinand Ako. I will be presenting on soil. Lessons objective. At the end of the lesson, as a student, you should be able to understand the physical properties of the various soil types, the classification of soils according to their textures, the component of a good soil, the human-induced cause of nutrient depletion in soil, and the measures to maintain soil fertility. An introduction. Soil, as we all know, is a mixture of mineral and organic material that is capable of supporting plant life. The result of the process, soil is a result of the process of gradual breaking down of rocks, such as weathering and erosion. Soil is made up of 4 basic constituents: the mineral materials, the organic materials, the air, and the water. Processes such as leaching, weathering, and microbial activities combine to make a whole range of different soil types. And of course, each type of soil has a particular strength and weakness for agricultural production. That is why it's basic and important that you analyze and know the kind of soil, and to also identify the one that best suits the crop you are about to grow. Types of soil. On the basis of their size, of the size of the particle matter that make up the soil, as of course the soil texture, soil can be classified as sandy soil that range from 0.1 to 2 millimeter in size. The particles range from 0.1 to 2 millimeter. We have the clay. Of course, the particles are less than 0.1 millimeter. And we have the loamy soil, which is a mixture of the mixture of sand, clay, and silt in appropriate proportion. Sandy soil. Sandy soil contains a high proportion of sand and less clay. It is light, dry, and warm, that tend to be more acidic than other soil types. Sandy soil also have low water retention capacity, and they have fewer nutrients. It's also less suitable for crop production because of the low content of nutrients. Not all crops are fitted for this kind of soil. But the soil can, however, be amended by adding organic matter to increase water and nutrient content. Of course, water and nutrients are very necessary for plant growth. For us to improve on the quality of this kind of soil, we need to amend it by the addition of organic matters. And what are these organic matters? Organic matters are decayed organic materials, such as plant materials, animal droppings, and other decayed matters. We have clay soil. This kind of soil is comparatively heavy as it has higher water retention capacity and a higher concentration of nutrients. Of course, clay soil is richer in nutrients than sandy soil we have seen earlier. It is made up of over 25% of clay particles that are smaller in size, and those hold a larger amount of water. It also drains water slowly. Therefore, it takes longer to warm up in the summer without drying out. It also does not provide space for plants, root to grow because of the high compaction in the soil particles. It has very low space for soil or plant roots or for plants to be rooted. have loamy soil. Loamy soil is a mixture of sand and clay at a right proportion. Since it's a mixture of the other kind of soils, it combines the properties of the two kind of soils and make it more fertile. It utilizes the aeration capacity of sandy soil with the high nutrient content of clay soil to make it more better fitted for plant roots. The soil, of course, has enough space or pores as well as water retention capacity to promote crop production. The level of calcium and pH as the acid-base concentration of the soil, of loamy soil, is also of appropriate amount due to the presence of inorganic matters. The table here gives a comparison of the physical properties of the main soil types. We have here the first column is the property of the behavior of the soil. We have the sandy soil, the loamy soil, and the clay soil. The first property here is water retention capacity or the porosity. The sandy soil is lowest in porosity. The loamy soil is higher to medium or medium to high, and clay soil is high in water retention or water holding capacity. Then we also have capillarity. Capillarity here is the ability of water to drain through the soil. Capillarity is low in sandy soil, is medium in loam soil, and high in clay soil. Humus content. As we established earlier, the sandy soil is low in humus, the loam soil is high, and the clay soil is medium. Aeration. Aeration here deals with the space between soil particles that allow air to pass through the soil. It is good in sandy soil, as is highly aerated. Then in loam soil is medium and is of course poor in clay soil due to the compaction of soil particles. We have the drainage rate. Drainage rate is the same as the aeration. A soil that is high in aeration or good in aeration will drain water faster and is also not prone to runoff erosion. The sand soil is high in drainage, the loam soil is medium, and the clay soil is low. Then the soil organic matter content. The organic matter content is low in sandy soil, medium to high in loam soil, and high to medium in clay soil. The decomposition of organic matter, that deals with how fast an organic matter can rapidly decompose in the soil. It decomposes very rapid in sandy soil, medium in loam soil, and slow in clay soil. Heat conductance or heat conductivity. The sandy soil conducts heat rapidly. The loamy soil conducts heat moderately and is very slow in clay soil. Compactability, that is how closely packed or closely arranged the soil particles are, is low in sandy soil, medium in loam, and high in clay. Susceptibility to wind erosion, that is how will this soil respond to the incidence of wind erosion. In sandy soil is moderate, except if the particles or the sand contain fine particles. It is high in loamy soil and it is low in clay soil. That means the loamy soil is highly susceptible to wind erosion. Then susceptibility to water erosion. Water erosion here deals with how fast or how the soil will respond to the incidence of runoff or water rain erosion. The sandy soil will respond slowly except if the soil contains fine sand particles. The loamy soil will respond high, and the clay soil, it is low to high. Then we have leaching potential. Leaching is the sinking of or the loss of nutrient from the topsoil due to seepages. The sandy soil leach very fast because of the high pores or low compactability or compaction in the soil. The loamy soil is medium, and it is very low in clay soil. Then we have soil structure. We say soil structure is determined by how individual soil granules clump or bind together to form aggregates. We have 5 major classes of soil structure or structural types. We have the platic structure, the prismatic structure, the columnar structure, the granular, the block, and the structureless. The platic structure. In this kind of soil, the units are flat and the plate-like, and they are oriented horizontally. We say the platic structure also is usually found in soft surface soil that have been subjected to leaching or compaction by animal or machinery. That means that you are likely to have this kind of soil structures when the soil is subjected to human pressure, continuous cropping that lead to leaching of nutrients, or compaction by use of machinery, animals trampling on the soil, or the human impacts from human food can also cause soil to assume this kind of structure. He said this structure or kind of soil tend to impede the downward movement of water, and of course if that happens, the plant root through the soil will also be impeded. The structure on your right show a typical platy structure of a soil. We have the granular structure. In this kind of structure, the units are approximately spherical or polyhedral, as can see on the structure on your right hand, and are bounded by curved or very irregular faces that are not carved out of adjoining pairs. They are common in the surface soil of rich grassland and highly amended garden soil with high organic matter content. This kind of structure are found in soil in grassland or rich grassland soils, and we are made to know that it's highly amended, a grass soil that is highly amended or interfered by human means of enriching the soil with high organic matter content. We say the soil mineral particles are both separated and bridged by these organic matter breakdown products, and the soil biota exudates. The biota means the living organisms in the soil that exude certain compounds. It could be their excreta in the case of the earthworm, or feces, or urine and other exudates, making the soil easy to work on. So the cultivation, earthworm, frost action, and rodent mix the soil and decrease the size of the beds, and this allows for good porosity and easy movement of air and water. This combination of ease in tillage, good moisture and air handling capacity, and good structure for planting and germination are definitive of a good soil structure. Therefore means that granular soil structure is a typical soil structure recommended for agricultural product or production. Have the prismatic structure. So the individual units of this structure are bonded by flat to round vertical faces. The units are distinctly larger vertically, longer vertically, and the faces are typically cast or mold of adjoining unit as seen in the structure at your right hand side. The vertices are angular or surrounded. The top of the prism are somewhat indistinct and normally flat. Prismatic structure are characteristics of the B horizon or the subsoil. The B horizon is the third horizon of a soil after you move from the surface to the A horizon, the B horizon, and the rest. So this kind of soil structure is commonly found in the B horizon. The vertical crack results from freezing and thawing and wetting and drying, as well as the downward movement of water and roots. We have the columnar structure. In this structure, the units are similar to prisms and are bonded by flat or slightly rounded vertical faces. Structurally, this columnar and the previous prismatic structure are alike as they are elongated, but while in the prismatic they are flat, the faces are flat and vertical. In that of the columnar, they are rounded or slightly rounded, and the top of the columnar, in contrast to those of prism, are very distinct and normally rounded. They are common in the subsoil of sodium affected soil. This kind of structure results from the subsoil that has been impacted or polluted by sodium or sodium compounds. Very dense, and it is very difficult for plant root to penetrate this layer. Deep plowing can help to restore some degree of fertility to this soil. These kind of structures impose a problem on the soil. It impairs the plant root from growing through the prisms, growing through the structures. However, if you can plow the soil, or the soil can be plowed, it can restore its fertility by breaking down the column into smaller structure. We have the blocky structure. In this structure, the units are block-like or polyhedral. They are bonded by flat or slightly rounded surfaces that are cast out of faces of surrounded pests. It's common in subsoil. It can also occur in surface soils that have high clay content. These structures are common in soil that are high in clay content. Sometimes the surface of the dry up slug and ponds showed characteristic cracking and peeling due to clay. This is a typical characteristics of a block structure of soil. Then we have soil porosity. Of course, porosity is one of the basic characteristics of soil that influence its productivity. A soil that is porous is prone to leaching, and also a soil that is porous is highly erected for plant roots to grow as well. So porosity here is defined by the number of pores that is present within the soil. The higher the number of pores, the higher the porosity. Porosity is determined by the movement of air and water within the soil. Porosity determines how air and water circulate within the soil. Of course, air and water are very important components of soil that is necessary for microorganisms to survive. And of course, microorganisms are very important in soil amendment. They say a healthy soil usually have more number of pores between and within soil aggregate, whereas poor quality soil have few pores or crack. The diagram on your right displays soil, the porosity of a soil. The first structure shows high porosity with large space. The second one shows low porosity with small spaces. You know, the space between soil particles determine the porosity. And then we say the soil porosity is also influenced by soil's texture and structure. Of course, the various structural components or structure that make up the soil determine how porosity is. From our previous slide, we saw that the prismatic and the columnar structure impaired water movement because of their low porosity. That is why they are not highly recommended for agriculture except amended. Then we have the pore size in soil affect the ability of plants and organisms to access water, oxygen, and other nutrients. We have capillarity, another important soil characteristics that determine its productivity. It refers to how well water rises up in the soil. It can be measured by the speed at which water rises in the soil and the extent to which the water rises. As can see in the structure on the right hand side, it can be demonstrated using this simple experimental setup by just inverting 3 cylinders in your basin. Fill each of them with soil, the 3 types of soil, and add water in the basin. You will clearly see that in sandy soil, the water rises very fast, and within a short period of time, it will pause and will not move again. In the clay soil, the water rises smoothly and keeps moving until it gets almost to the top of the soil, while in loamy soil, it moves in average, but it will get to a limit quite lower than that of the clay. We say the capillarity depends on the size of the spaces between soil particles. From the experimental setup, it's shown that the spaces between particles in sandy soil are larger. That is why the water moves really very fast, and within a short period of time it pauses, while that of the clay soil are very compacted and water moves continuously through the soil. How the smaller the space, the higher the water rises in the soil. Therefore, in our setup, the water in clay soil, the clay soil allows water to rise highest compared to sand soil and loam soil. Then water tends to rise very fast in sand soil, but after a while it slows down. Then the water not rise again. Clay soil allows water to rise slowly but higher. Then the capillarity helps in making groundwater rises and available for the plants on the surface. Have a component of soils. So the basic component of soils are mineral or inorganic matter, organic matter, water, and air. A typical soil consists of approximately 45% mineral, 5% organic matter, 20 to 30% water, and 20 to 30% air. The amount of each of the 4 major components of soil depends on the quantity of vegetation, soil compaction, and water present in the soil. This means that, for instance, the soil that is in the area covered completely or adequately covered with vegetation will likely have higher organic matter content, while the soil in areas that have been always subjected to human fertilization or application of inorganic fertilizer will likely be higher in mineral or inorganic matter. So a good soil or a good or healthy soil has sufficient air, water and mineral materials that promotes and sustains life or plant life. The diagram here illustrates this composition. Now have, what do we understand by soil quality? What do we mean when we say the quality soil is of high quality? So the quality of the soil is defined by its capacity to function for specific land uses or within ecosystem boundary. Such indicators as organic matter content, salinity, tilt, compaction, available nutrient, and rooting depth help measure the health or condition of the soil and its quantity in any given place. Organic matter content, biological activity, acidity, and salinity are related to the ability of the soil to store and recycle nutrients for plant growth. So we have what practices or processes that reduce soil quality. What are those things that naturally or humanly induce that reduce soil quality? He said any practice or processes that alter soil composition will ultimately reduce its quality. Like the composition, the component of the soil we listed before, the organic matter, the inorganic matter, the water and air. If there's any obstruction, anything that alter them from that regular composition, it will likely reduce the quality of the soil. So some of these human activities or human-induced processes that reduce soil quality are or include repetitive tillage. When you till a soil continuously over a period of time, the soil will lose its structure and will become prone to erosion or runoff, then or leaching and other processes that reduce the quality of the soil. Vegetation burning or burning of vegetation. Vegetation, of course, provides the coverage for soil and preventing from wind and water erosion, preventing from excessive dryness and other properties. Whenever the vegetation is burned off, litter is getting right off from the soil, and decaying organic matter reduced, as well as the microorganisms that are lost to the heat from the burning. Then we have loss of inorganic matter, loss of mineral, loss of weathering component that build up the soil will definitely affect the quality of the soil. Then we have compaction. Compaction, of course, can be induced by animal grazing on the soil. Grazing, on the crop on the soil can be caused by machines like tractor, plow, and others working on the soil, or even by human feet on the soil that makes the particles more compacted than the normal way and reduce aeration in the soil. That can be a very dangerous practice that reduce soil quality and of course ultimately affect the yield. Leaching. Leaching here have to do with the loss of nutrient from the topsoil. Whenever the nutrient is getting off from the topsoil through leaching, the nutrient will no longer be available for shallow rooted crops, especially when it's leached beyond the reach of even deep rooted, it becomes a problem for any kind of crop to grow. Then we have erosion of the topsoil. Of course, is one of the greatest enemy of soil quality. It can wash away the topsoil that is rich in organic and inorganic materials and also microorganisms. and leave the soil bare and degraded. And if this continues over a time, the ability of the soil to recover naturally may not be there. So it will need human intervention in one form or the other to revive the soil. Then we have repeated cropping. Continuous cropping of the same crop over and over again on the same soil can affect the soil quality. It adds nothing to the soil but keeps on removing certain nutrients that the plant might need from the soil. So it also results in degradation of their micro environment of the soil or living organism, or micro environment of the living organism in the soil. And we have what is soil fertility. The ability of a soil to sustain plant growth by providing essential plant nutrients and favorable chemical, physical, and biological characteristics as a habitat for plant growth. That defines what soil fertility is. Then a fertile soil has the ability to supply essential plant nutrients and water in adequate amount and proportion for plant growth and reproduction. If a soil has lost its ability to supply essential nutrients and water in adequate amount for plant proper growth and reproduction, the soil is no longer described as a fertile soil. And the fertile soil is also characterized by the absence of toxic substance which may inhibit plant growth. It's not all about having the nutrient that matters, but whenever the effort of the nutrient is impeded by pollutants or compound that inhibit plant growth, the soil is no longer described as being fertile. Then we have the fertile soil also have sufficient soil depth for adequate root growth and water retention. If a soil must be fertile, it cannot just be a slab. It cannot just be the size that will not support plant growth. The depth must be sufficient enough for a plant root to penetrate and have enough water for the plant to feed or to derive pollution on. A fertile soil must also have good internal drainage. That is the drainage system that allows sufficient aeration for optimal root growth. Then we define aeration earlier, that is the ability of the air and water to seep or to circulate through the soil. So a fertile soil must have drainage, internal drainage system. The space and pores must be large enough to allow sufficient penetration of root system. Then we have this fertile soil must also have sufficient soil organic matter for healthy soil structure and soil moisture retention. The healthy fertile soil, of course, must have a pH in the range of 5.5 to 7, as the soil must have some level of acidity in it. It must also have adequate concentration of essential plant nutrients, just as the structure you see on your right hand shows is a fertile soil that is capable of sustaining plants by providing essential nutrients. Then we have what do we mean by soil fertility decline? We said it occurs when the quantity of nutrients removed from the soil in harvested produce exceed the quantity of nutrients being applied. Whenever nutrient is being rid off from the soil in the quantity that exceed the recruit amount, we said the soil has declined in its fertility. He said it results in reduction of plant growth and yield. Of course, whenever a soil fertility is reduced, it reverses the performance of the plant drastically, as seen on the picture on the right hand. field was subjected to some kind of decline in fertility, and the plant started, wilting. He said offside loss of nutrients can also occur through offside loss of nutrients, as decline in fertility, can occur through continuous cropping with stable or stubble crops. When you continue growing certain crops continuously on the same piece of land over years, over time, there is possibility that the fertility will decline. The nutrients that are being consumed by that plant will be raised from the soil. Then we have soil erosion can also cause decline in fertility. Leaching can also result. Runoff, burning of the fields can also cause same issue. Then can also be accelerated by frequent tillage. When you continuously till the soil, it will affect the fertility. Then how do we manage this fertility decline? He said the fertility management aims to maintain soil organic matter, soil structure, soil nutrient status, and satisfactory soil pH. Whenever we say we are managing the fertility decline, what is our aim? The aim is to maintain the soil organic matter, to maintain the soil structure, soil nutrient status, and pH from being affected. This can be achieved in cropping system by including pasture phases and leguminous crops. When you grow your field that you are suspecting fertility decline, or you want to prevent the decline in future, what you simply do is to include leguminous crops in the field. As we all know, leguminous crops, fix nitrogen to the soil and make the soil richer. So by the cause of their root nodules, they fix nitrogen to the soil and replenish the lost nutrient. We also include the addition of soil amendment or fertilizers. We can amend the soil using inorganic or organic fertilizer, as the case may be. We may employing a reduced tillage system. Instead of every year tilling before cultivating, you may decide to adopt other systems of planting without tilling. Then retaining crop residue on the field. When you harvest your crops, you don't take the residue out. You don't take the straw out of the field. You retain them in the field so that they will decay and build up the organic matter in the soil. You can also use contour ridging to reduce the incidence of erosion in the field. It can help to reduce fertility decline. Terracing is also another important concept you can use. You can also use mulching. You cut grasses and cover the field so that it can retain more moisture, organic matter, and microorganisms. You have polycropping, grow several crops in the field so that when the other crop is taking excess of the nutrient, the other one will replenish it. Then strip cropping is also important. The use of organic and inorganic fertilizer, and of course, very important is crop rotation. In crop rotation, our conventional method of rotating crop continuously, allowing the land to fallow for a period of 4 years, and you repeat it with the same crop, can be, amended. You can also have the fallow system of 2 years, by rotating the crop between with another crop. The picture here shows the use of natural mulching to control nutrient loss from topsoil. Then we have strip cropping, can also be used when the slope is too steep or too long. Then this is a typical crop rotation approach that can be used. You can have a fallow period reduced and rotate the crop, between another with another crop instead of continuously rotating the same crop year after fallow. Then assignment. You have to do this assignment at home at your covenant. You describe how can you identify the kind of soil you are working with, and also describe the attribute of the soil you will recommend for your family's vegetable garden. Thank you.